Welcome back. This is the third lecture in number system series. So in the earlier previous two videos, I have give you the details about the number system, how to convert a decimal number into binary as well as octal number system and hexadecimal. In this lecture, we're going to see the reverse one. So how to convert a binary number to decimal first, and then also you're going to see how to convert a octal number to decimal, and similarly you're going to see how to convert a hexadecimal number into decimal one by one. Okay, so let's pick the first one. Let's see how to convert a binary number to decimal. Okay, so let's take a binary number over here, 1 0 1 1 1 0 1, and 2 is the base. Okay, so what we knows? We knows that a binary number can be formed using these two digits only, ones and zeros. So now let's see actually what is this in decimal. Okay, what is this in decimal? So how to do that? How to do that? So before you start calculation, what you need to do? Just rewrite this number here again, and make some spaces between the digits. Done. And what next? The next is number their position. Start it from this side. 0th position, first, second, third, fourth, fifth, and sixth is their position. Okay. So now let's see the formula, how we can convert this number into decimal. We're going to use with the 2. Okay. Earlier, if you remember, when you're converting a decimal to binary, we have divided by 2. Now you're going to multiply it. See the formula. 2 to the power that particular position, 6, and multiply with this number, 1, plus 2 to the power that position, 5, multiply with that number, 0, plus 2 to the power that position is 4, multiply with the particular number as 1, then plus 2 to the power the position 3, and that particular number multiply with this. Again 2 to the power the position is 2, and that number is actually 1 here. And next 2 to the power 1, and the number is 0. Here you can see. Okay, number is 0. And at last I am putting it here because there is no space. Just wait, let me make some space so that it can be framed under one picture. Yes, so now next is 2 to the power 0, and that multiplied with 1. Okay, so that solves this problem only. 2 to the power 6 is 2 to the power 6 is 64. Next, multiplying with 0, so no mean to do that. 2 to the power 4 is 16, plus 2 to the power 3 is 8, plus 2 to the power 2 become 4. Again multiplying with 0, there is no meaning. 2 to the power 0 is 1, 1 into 1, it becomes 1. So if I now sum up this number here, 64 and 16 is 80, 80 and 8 is 88, 88 and 4, 92, plus 1, 93. 93 is the number into decimal. So I hope you understand the process here. You can watch the video again and again so that you can understand the process. So let us check it here again, that this is actually the equivalent decimal number of this binary or not. So what to do? You simply just divided the number by 2 again. So here we get 46 divided by 2, remainder is 0. 23 divided by 2, remainder is 11. Sorry, quotient part is 11, remainder is 1. Divided by 2, it becomes 5. Remainder is also 1. Divided by 2, remainder is also 1. Quotient is 2. divided by 2, quotient is 1, and the remainder is 0. So if you again just place this number from bottom to top, we'll get this number back. Yes, 103101. So whatever the process we have followed, yes, it is correct that 93 is the equivalent decimal number of this binary number. Got it? So now let's do the second part, convert an octal number to decimal. So you know how to represent an octal number with 8 digits only, 0 to 7. Okay, so what are you going to do? We're going to do octal to decimal. Okay, earlier we have shown the reverse one, just dividing with the 8. So let's take a number here. Suppose 176. It is in octal. And what we want? We want it is in decimal. So what to do? The same process, just like binary we did. In binary we did it with 2 to the power something. So here is their position. So let's just write it little bit, mix our space. Yes, here is the position. And now let's solve this problem. So what you can do, instead of 2 to the power something, what you can do, you need to use 8 to the power, the position is 2, multiply with 1 plus, so there is the position here and here is the number. Again 8 to the power 1 multiply with 7 plus 8 to the power 0 multiply with 6. So 6 comes here, 7 comes here, and others are the position. So 8 to the power 2 is become 64, okay, and so multiplying with 1, it hardly change anything, plus 8 to the power 1 is 8, 8 into 7 is become 56, plus 8 to the power 0 is 1, 1 into 6 is become 6. So now if we just sum it down, 6, 6, 12, 12 plus 4 is 16, and over is 1, 5, 1, 6, 6, 6 become 12. So this is what? This is the equivalent decimal number of this octal number. Let us just check with the calculator. Okay, so here we can check if we just take a number in decimal here, decimal 126. So you can see the octal number 176. Okay. So that means our process is correct. Okay, so now without any further delay, let's complete the last part. So next what we're going to do, we're going to just convert a hexadecimal number to decimal. So let's take a number. We know that hexadecimal number can represent using 16 different combinations of number and alphabets, 10 alphabets and 6 characters. So let us take a number here. Suppose 17A12 is the number in hexadecimal. So what do you want? We want in it should be the equivalent decimal number. So method is very straightforward. What we need to do? We need to make it 16 to the power something. Correct. So let's just make certain space between the digits. 1, 7, A, 1, 2. So here is their position. 0, 1, 2, 3, and 4. So now let's do this. This is 16 to the power, the position is 4, okay, multiplying with 1 plus 16 to the power position is 3, multiply with 7 plus 16 to the power 2, what is A? A means 10, so multiply with 10, okay. So see this our earlier videos in number system, because in number system A represents 10 in hexadecimal. Then next what left? 16 to the power 1 multiply with 1, and at last 6 to the power 0 multiply with 2. Okay, so we need certain calculator over here. 16, let's multiply 16 4 times. 16 into 16 into 16, sorry, into 16. So this is the number 113020, 113020 plus 16 to the power 3, 16 multiply with 16 multiply with 16, 5270, and multiply with 7. Now 45410 plus again 16 to the power 2, so 16 square 304 into 10, so it's become this 16 and it becomes this. So let's just add this number so that we can get the correct number in decimal. So 113020 plus 45410 plus 3040 plus 16 plus 2. So we get the number. It is no, it is not correct. Oh. Let's start converting a hexadecimal number into decimal with an example. Okay, so just it's like similar to the octal number actually. Previously we have get the power of 8 and multiply with the particular number. So similar thing here we'll do. Instead of 8 we'll use 16 here. So let's just take a number here. So 7, suppose E, and suppose 12 is the number. Okay, so let's just place this number. This is in hexadecimal. So we want its equivalent by decimal number. So let's make some space between the numbers and alphabets. 1, 7, E, 1, 2, and let's put the position. Okay, so we've done the positioning here. So now let's calculate. That should be 16 to the power 4 multiply with 1 plus 16 to the power 3 multiply with 7 plus 16 to the power 2 multiply with E. So we know what is E. E is actually 15. Is it? No, E is not 15. E is actually 14. 14. 14. Plus 16 to the power 1 multiply with 1 plus 16 to the power 0 multiply with 2. Okay, so very simple and straightforward method. Let us calculate this 16 to the power 4. What is the actual number? So let us use the calculator. 16 to the power 4. So let me just change the calculator in scientific form. 16 to the power 4. 16 to the power 4. So we get this number 65536. 65536. 65536 plus 16 to the power 3 into 7. So 16 to the power 3 into 7, we get 28672. 28672 plus 16 to the power 2. So let's calculate 16 to the power 2 into 14. We get the number 3584. 3584 plus 16 to the power 1. The position is 1. So it is 16 plus it will be 16 to the power 0 is 1. 1 multiplied 2 is 2. So let's just quick addition of this number. We have the first number here 65536. 65536 plus 28672 plus 3584 plus 18. So here is the number 97810. 97810 into decimal number system. So let us check this number is equivalent to this number or not. So let us move back to the calculator of type programmer. Okay, and let's type this number into decimal. 97810 810. So here you can see the number in here in hexadecimal format 17E12. 17E12. Okay, so very straightforward to conversion the number hexadecimal to decimal. So hope you are enjoying these tutorials. Please comment if you need any other kind of video, anything from the C programming. So by that time, bye bye, enjoy, and don't forget to press the bell icon for subscription of the channel. Thank you very much.